I'm going to talk a little bit about stock and flow, and what this is you can imagine a stock is something that, I usually draw it as a box. It holds something. The thing that it holds could be water, like a bathtub. It could be carbon dioxide, like our atmosphere. It could be how much good feeling you have towards somebody, which is a little bit more amorphous, but we can still use a stock and flow model to think about that. The water flows into and out of the stock, or whatever it is. It could be water, it could be carbon dioxide, which is being added by cars or factories and taken out by trees. But you can look at it as a stock and flow in either case. And the idea behind a stock and flow is that you have stuff going in, and that's modeled as a faucet, kind of like a faucet on in your bathroom or in your kitchen. And then you have stuff going out, which is also modeled as a faucet. You can think of it as a drain if it's in your bathtub. But you'll see it drawn like this on some of the applications we'll use. That'll be the typical way to do it. And I think Meadows uses something like that. She has like a faucet in her drawings as well. And what I like to do is on, not just me, what systems folks like to do is we wonder, where does the stuff come from that is going to go in and fill in this stock? So if it's water, maybe it's water that's filling it up like this. Where does that water come from, and where does it go? And what we use is a cloud metaphor, so that the water comes from a cloud. Perfectly appropriate metaphor for water, isn't it? And that cloud means we really don't know where it comes from. It doesn't mean it's coming from a cloud. It's kind of a symbol for the unknown, or the things we're not even considering. And it also goes to the cloud. So after we release the water from our drain, it goes somewhere, it goes away. And for the purpose of our model, the cloud represents the boundary that we don't know or care about or not considering as we do our systems thinking. So that's the general idea behind a simple stock and flow model, and that's what we're going to spend a little bit of time looking at in the rest of this video, and we're going to use some of the approaches that Meadows discusses in her book as we consider stocks and flows associated with a bathtub. The first thing I want to have you think about is let's assume that there is no flow out, so we can even ignore this part here. I can erase it. This just means we have water flowing into the tub. I'm not going to even show the water flowing out, or I can say it's flowing out, but it's zero. And let's just say that initially the tub is empty. So I'll just say it starts at 0, so I'll make that more explicit. I'll put no water in here. And I'll say, what if the water is flowing in and it looks like this? So I'm going to draw a graph to show you how the water flowing in looks. It looks something like this. This is time. So one of you mentioned, this is going to remind me of middle school algebra. Well, it is a little bit. There's a little bit of that kind of thinking in here. So let's use it because we need to know it. You learned it for a reason, and we'll be able to apply it here, hopefully in a really practical way, that if you didn't like middle school algebra, maybe you will like it more now. And it's not exactly algebra we'll be doing, but it's that kind of thinking. So let's just imagine we have water flowing into this tub, and this is the rate at which it's flowing in, and I'll say it's in gallons per minute. All right, now I'm going to say we just turn on the tub. So we wait a little bit, we get into the bathroom at time 0, and at 1 minute, we turn it on, and it's flowing into the tub at 2 gallons per minute. And we do that for, 2 gallons a minute isn't all that much, but let's say we do it for 10 minutes. So that 1 minute is when we start, 11 minutes is when we stop. So the question is, if this is what's flowing in, then what is going to be in the tub? I'll give you a moment to think about that, and then I'll do it here. So hopefully, after a little bit of reflection, you came up with something like this, and if not, don't worry. I'll draw it in red. Let's say this is what's in the tub itself, let's say. Well, for the first minute, nothing happens. So the tub's empty. But after that minute, every minute thereafter, this is the water in tub. Gallons of water in tub. After 2 minutes, you've had 1 minute of water flowing in at 2 gallons per minute, so it went from 0 after 2 minutes. It's going to be at 2. After 3 minutes, it's going to be at 4. After 4 minutes, it's going to be at 6. It's just going to keep going up until you reach 11 minutes. What happens at 11 minutes? Well, nothing is added, nothing's taken away, so it remains constant. And it should be constant, and if you do the math, it would be 20 gallons. So it would reach 20 gallons. Whoop. At 11 minutes. There's a gap here, of course, but it would look like a a line that angles up, constant slope, because the water is being added in at a constant rate. So this is what the tub would look like. And you don't necessarily have to be able to calculate this all the time, but I want to give you an intuitive feeling for it. Okay, we'll do another example in just a minute or in the next portion that takes this and then lets some of the water out. Okay, continuing on this logic, let's try another thing. Let's say now not only do we have an input, but we also have, which is this, over here. I'll do color a different color. Here's our input. That's our flow in. Let's now create a flow out and then reevaluate what the graph looks like. So I'm going to erase the old graph. These iPads are so nice. Okay, and now I'm going to create an outflow, which will look like this, as I showed you earlier. It's my faucet, and it's going to a cloud. All right, so now let's say the input's the same. Let's say, okay, it's coming in at 2 gallons per minute. And then let's say it's for 11 minutes, that's the case. And then at some point later, this guy here, I'll draw a graph of it. I'll draw this graph in a different color so we can distinguish it. I'll do it a dark blue. So for this one here, let's say, okay, at 11 minutes, that's when this one fills up. So this is rate out. In gallons per minute. And I'm going to say, okay, if you're going to take a bath, you're going to fill it up, you're going to hang out in it for a while, so it's full by 11 minutes. So let's say you take, I don't know, a 20-minute bath, 19-minute bath, so it's an even 30 minutes. And then the outflow, I'll say, the flow is leaving the tub at 2 gallons per minute, and I'll say that it's doing that for, it can't be any more than 10 minutes, because that's more water than is in there. So you can only drain out as much as it's in there. So I'm going to say the out-draining part looks the same as the in-draining part. it's harder to see it on this graph because I ran out of space. But this here is 40 minutes. So between 30 and 40 minutes, it's draining out. Between 1 and 11 minutes, it's draining in. Let's see if we can graph what the full tub is going to look like over this time. So here's what I'll do. Draw a time, nice long time here. And nothing happens the first minute, but then it fills up. We already showed you this one in the last little example with just an inflow. So this is the stock. This is the, I'll call it the stock if you like, or water in tub, which is in gallons. It fills up to, well, we already talked about that. 2 gallons a minute for 10 minutes. It's 20 gallons full. That's how much is in the bathtub. And it's going to stay 20 gallons full until 30 minutes. Between 11 minutes and 30 minutes, I should say, it's staying constant. And then we pull the plug, and it's going to drain out at the same rate it drained in. So at 40 minutes, we're back to 0. Okay, so this is the basics of stock and flow applied to the bathtub problem. Now we could do all sorts of other things, and we'll talk about other things we could do. We could have more than one inflow. We could have more than one outflow. The inflow doesn't have to be constant. What if the inflow increases or decreases, or vice versa for the outflow? So you get all sorts of things happening to the stock in these different situations. But this gives you an initial picture of what you can do with a stock and flow diagram.